Hello, ladies and gentlemen, and welcome back. We are at problem number 3 now, so midway through part 2 of the Alberta math contest from 2010-2011. On the side BC of triangle ABC are points P and Q, so that P is closer to B and Q than Q. And we know that angle PAQ is half angle BAC. I'm going to start drawing this. A up here, B and C, and P here, and Q here. So P is closer to B there. And then PAQ this angle here is a half the whole angle BAC. Okay. X and Y are on AB and AC. X over here and Y over here. So that XPA, this angle in here, is equal to APQ. Okay, let's redraw that so it's a little nicer. About this angle, so we'll say X is about here-ish. And YQA is AQP. This angle, so I guess we'll put Y about here. Oops, lost the whole side of a triangle. Okay. And then, so we've got those. Prove that PQ is PX plus QY. So PQ is PX QY. Which doesn't quite look it in my picture, but that's okay. What can we do here? So I know this angle up here is twice this angle. Now if I call this angle here little x and this one little y, that would mean that this has to be x plus y. Now the reason I'm focusing on this is they're telling me angles here. Okay, that's all they've really said is angles, but now they want me to make a conclusion when it comes to lengths. So PQ is PX plus QY. Oh, we could try and draw some circles here. So a circle centered at P and maybe a circle centered at Q. And these ones should be sort of just tangent to each other right here. I should be able to find some point, maybe call it R, so that PR is PX and RQ is QY. So that's something I'd like to do. What else can we do here? I should probably write some of this down. So, well, no, let's get a plan before we start writing up our solution. So I'd like for this to be the case, if the statement they want me to prove is true, I should be able to find such an R. But I can't just say, well, let R be the point on PQ so that PX, because I don't know that that's actually true. Now, am I going to have a right angle here? Is it going to be, is AB tangent to my circle? So if we call this angle P and this angle Q, this is Q. P plus Q plus X plus Y should be 180. I've got a Q and a Y, so I should get P plus X here, Q plus Y here. I can't say for certain that either of those has to be 90, so the AB or AC might not necessarily be tangent to these circles. We would get a mutual tangent here, but there's nothing I can really do with that. That's just going to stick up perpendicular out of here. Oh, what could we do here? They told me about the angle up here, or the two angles there, and I've sort of split it up. And we've got angles down here, but I don't have any actual length, so we're going to have to do some sort of construction. Could we do... Instead, so I know this R is here, so instead of drawing a tangent line, if I were to connect it up with A, I know that in the end I should get this length is this length, and this length is this length. But how would I... Oh, you know what? This is X and this is Y, and I can always draw a line so that we get an angle here of X and and then therefore you'd get an angle here of Y. It looks like Y, Q, and then what's left over must go here, and then what's left over on the other side must go here. Those must be the same. Okay, it's congruent triangles. That's what we need to do. Congruent triangles. So let's write this up. Draw my picture again. Here's A, P, Q, X, Y. Okay. So I'm going to say let XAP be little x, and let YAQ be little y. So we get little y here, x here. Now, angle BAC is twice angle PAQ, but it's also angle PAQ plus x plus y. So I conclude that angle PAQ equals x plus y. So now we'll say let R be on PQ so that PAR equals x, and therefore QAR equals y. So now we've added in this line that I was sort of wanted to make. So that's what we've just done, and so this is x, this is y. Okay. Now, this angle is the same as this angle. This angle is the same as this angle. Therefore, these angles are the same. And we've got a side in common, AP. So we see triangle APX and triangle APR have angles XAP equal to angle RAP, and angles XPA equal to RPA, and have common side AP, so they are congruent. And as long as we've got this nice little picture here, we can just say similarly AQR and AQY are congruent. Or you can write the same thing up, but you need one side and two angles to be the same. Okay? So angle side angle congruency. And then, so similarly, triangle AQY is congruent to triangle AQR. So we'll say then it follows that XP is the same as PR, and YQ is the same as QR. PQ is PR plus RQ. Why is that true? Because R is on PQ. Okay. But then that's PX and QY as desired. There we go. So we just had to play around with it the right way. Looks like nothing really happened with these circles, but it could have been a circle geometry question. It turns out it was a congruent triangle question, and that's just as good. Okay? So it was really all about spotting, oh, they want me to break PQ up and show that that length is the sum of these other lengths. Anytime that happens, it means you can find a point on here that splits this up into 2 points. And so sometimes it's useful to fill in, well, when you're doing geometry, fill in the condition that they ask you to prove and say, well, what could we do there? What could we imply? How do we work backwards from this rather than just sort of staring at it hoping to get a construction? I made these circles. They didn't go anywhere. Instead, we had to sort of imagine this line here. But we couldn't just say, there must be a line, because you're assuming you know the correct answer. So we had to find a way to make that line, and it was spotting the angles splitting up that we really needed there. Okay, so that's question number 3 done away with. We are over the halfway point now. Up next is going to be question 4, so feel free to join me for that one in the following video. Take care and have a wonderful day.